Hey everyone, and welcome. Today, we're going to break down the absolute bedrock of JavaScript, data types. You can think of them as the basic grammar of the language, the building blocks you're going to use to build, well, everything. So let me just kick things off with a question for you. How does a computer, a machine that really only understands ones and zeros, know that the word code is, text, and that the number 100 is something you can do math with? I mean, to a machine, they're not obviously different. It needs some rules. It needs a system. And that system, well, it's actually super easy to picture. It's all about putting your information into the right kind of box. For this whole explainer, I want you to imagine that every single piece of data in our code gets stored in a special box, one that's designed to hold just one kind of thing. Okay, so let's make it official. What are data types? They're really just labels for our data, telling the JavaScript engine what kind of variable box we're dealing with. But, this is where JavaScript is a little bit special. And honestly, it's what makes it so flexible. See, JavaScript has this thing called dynamic types. Now, what does that mean for our box analogy? Well, it's pretty cool. In a lot of other languages, if you have a box that's made to hold numbers, it can only ever hold numbers, period. But in JavaScript, that same box could hold some text 1 minute, and then you could dump it out and put a number in it the next. It's incredibly flexible. So with that in mind, let's get into the most common types of boxes you'll be using pretty much every single day. These are your workhorses, your bread and butter, the ones you'll be reaching for constantly when you're writing code. First up is the string. This is your text box. Anytime you want to store a word, a sentence, somebody's name, really any piece of text, you put it in a string. And here is the one rule you just cannot break. You have to tell JavaScript it's text by wrapping it in either single or double quotes. That's non-negotiable. And here's a perfect example. We're creating a variable we're calling name, and we're putting the text ChiruCodes right inside it. See those quotes? That's you telling JavaScript, hey, this is just text. Don't try to run it as a command or do math with it. All right, next up, our number box. Now, some other programming languages will actually make you use different boxes for whole numbers versus numbers with decimals. JavaScript, though, it keeps things super simple. There's just one number box, and it can hold both. So convenient. For example, here we've got a variable age holding the whole number 50, and another one, price, holding the decimal 10.5. They both use the exact same number data type. And notice, no quotes needed here. That's because these are actual numbers we can do math with. Okay, so beyond just text and numbers, we've got some specialty boxes. These are the tools you pull out when you have a very specific job to do, like handling absolutely massive numbers or making logical decisions in your code. Now, our standard number box is pretty big, but it does have a limit. It can safely and accurately handle whole numbers up to this enormous number right here. So what happens when you need something even bigger? What if you're working with, say, complex scientific data or something? You grab a bigger box. This is where BigInt comes in. It is literally the really, really big number box. It's designed for one specific job, handling integers that go way beyond that safe limit, making sure your huge calculations stay perfectly accurate. So how do you tell JavaScript that you need this special, oversized box? It's simple. You just add the letter n to the end of your whole number. That little n is the signal. It's the secret code that tells JavaScript, hey, bring out the BigInt box for this one, not the regular number box. Okay, now for a totally different kind of specialty box, the Boolean. I want you to think of this one as a simple on-off switch. It can't hold text, it can't hold numbers, it can only ever have one of two possible values, true or false. That's it. It's either on or it's off. So, let is coding equals true. It's just a statement of fact. And this is the foundation of all decision-making in code. Is the user logged in? True. Has the payment gone through? False. This simple little switch is what powers all those if-else statements that make our programs feel smart. All right, let's get into the two types that trip up almost every single beginner. I'm talking about the empty boxes. They seem really similar at first glance, but I promise our box analogy is going to make the difference crystal clear. Let's tackle undefined and null. Let's start with undefined. This is the untouched box. So imagine you declare a variable. You type out let my box. You've basically just told the program, hey, I need a box, and the program gives you one, but you haven't put anything inside it yet. Its state by default is undefined. Now, null is different. This is the intentionally emptied box. This isn't a default state. This is when you, the programmer, go to a box that maybe had something in it before and you deliberately emptied it out. You are actively saying, this box contains nothing, and I mean for it to contain nothing. It's on purpose. So right there, that's the crucial difference. Undefined is passive. It's an untouched box that's just waiting for a value. Null is active. It's an intentionally empty box where you, the coder, have assigned the value of nothing. It's a subtle distinction, but a really important one.
Okay, we've looked at a whole bunch of different boxes, right? Text boxes, number boxes, these little on-off switches, and even the empty ones. But why does knowing all this matter so much? Let's bring it all home.
This right here, this is your core toolkit. Everything we've covered, the string for our text, number for our math, BigInt for those massive values, Boolean for logic, and of course the empty states of undefined and null. These are the fundamental pieces you'll use to represent every single bit of information in your programs.
And that's because a program can't just add two words together like they're numbers, and it can't check if the number 50 is true. You have to use the right tool, the right box, for the right job. Understanding these types is the absolute #1 first step to making your code stop being just a list of instructions and start actually doing something meaningful.
So you've got the building blocks down. You know what goes in the boxes. But that leads to the next big question, doesn't it? What happens when you try to mix them? What do you get when you try to add a string to a number? Now that is where things get really, really interesting. But that's a story for another time. Thanks so much for joining me.